Hi students, welcome back. Today we are going to solve add binary problem on LeetCode. So let's head to the problem statement. The problem statement says we are given two binary strings A and B. We have to return their sum as a binary string. So the given inputs A and B are in the form of binary strings and we have to return their sum as another binary string. The constraints given are A and B are in the range of length of A and B are in the range of 1 to 10 power 4. That means A and B will have at least one number in them. A and B consists of only zeros and ones. Since it's a binary number, it contains only zeros or ones. Each string does not contain leading zeros except for the zero itself. So there can't be a case where there are leading zeros. For example, an input like this is not possible. This will come as 1 without the leading zeros. Whereas if the input itself is 0, then that is allowed. So this will come as 0. Okay. So let's see an example. So in this example, we are given two numbers A and B. A is 1 1 in binary notation. Okay, 1 1 in binary, which is base 2. That means this is nothing but 1 into 2 power 1 plus 1 into 2 power 0, which is nothing but 2 plus 1. 2 power 0 is 1, which is 3 in base 10 or decimal notation. Similarly, B is given as 1 in binary notation, which would be 1 into 2 power 0, which is nothing but 1 in decimal notation. So, A plus B is nothing but 3 plus 1, which is 4. 4 we need to convert to binary again, which would be 4, 2 2's 4, remainder 0, 2 1's 2 0. So 4, which is in decimal notation, is 100 in binary notation. Okay, which is our answer. Let's look at another example. In this example, we are given A as 1001. So A is 1010 in binary notation, which would be 1 into 2 cube plus 0 into 2 square plus 1 into 2 power 1 plus 0 into 2 power 0, which is nothing but 2 cube is 8, 0 into anything is 0, 2 power 1 is 2 and 0, which is 10 in decimal notation. Similarly, B is 1011, which would be 11 in decimal notation. So, the answer would be 10 plus 11, which is 21. You have to convert 21 to binary notation, which would be 2 tens, remainder 1, 2 5s, 2 2s and 2 1s, which would be 10101, which is our answer. So, to solve this problem, one approach is converting the given string to a decimal number, two strings, and then doing a normal integer addition and then converting the integer to binary again. But obviously this is not very efficient and it won't be able to hold the huge or large numbers. So let's look at a different way to solve this. So when we are performing binary addition, let's see the different cases we observe. So the different cases we observe are when both x and y are 0. When we are doing x plus y, if both x and y are 0, then the value would be 0 and carry would be 0. Okay. If x is 0 and y is 1, then 0 plus 1 is 1. So carry is still 0, value is 1. If 1 plus 0, it's the same thing. If it is 1 plus 1, 1 plus 1 is 2. There is no 2 in binary notation. So how is 2 represented in binary? 2 is nothing but 1 0 in binary, which means 1 is carry and 0 is the current place value. Okay. There is one extra case, which is when there is a carry of 1 as well, which is when we will perform 1 plus 1 plus 1. In this case, 1 plus 1 plus 1 is 3, which in binary will be represented as 1 1, which means this is the current place value and this is carry. Okay. So when it is 1 plus 1 plus 1, carry would be 1, current value would be 1. Okay. So let's take another example and see how we can solve this problem. Let's say we are given A as 10101 and B as 111. Okay. So now when we perform the addition, we have to start from the least significant bit, which is at the end of the string. So we have to start from the end of the strings. So here we have two ones. So if we see two ones, it's nothing but carry 1 and value 0. Okay. So carry is 1, value is 0. Again we have two ones. 1 plus 0 plus 1 is nothing but two ones. So again value is 0, carry is 1. When we have three ones, it's 3, which is represented in binary as 1 1. So value is 1 and carry is also 1. Here it is 1 plus 0, it would be 1. Here it would be 1. Okay. So this is our answer. Okay. So how do we determine value and carry in each of these cases? So value, if you observe, is always percentile 2, which means if you add two numbers, okay, let's say the answer is 2, the remainder when you divide by 2 is 0. Okay. If the value is 3, 1 plus 1 plus 1, when you divide by 2, the remainder would be 1. If the value is 1, okay, then the remainder when you divide it by 2 would be 1. If the value is 0, remainder when you divide by 2 would be 0. So the value in as seen in this chart is always percentile of the integer addition value. So this is nothing but 0 percentile 2. This is 1 percentile 2. Percentile is remainder in Java. Okay. 1 percentile 2. Here it is 2 percentile 2. So when you divide 2 by 2, there is no remainder. This is 0. Here it is 3 percentile 2. Okay. Similarly, carry is divided by 2. So there is a carry means there is something more than 2. So which is 0 by 2. 1 by 2. 1 by 2 is 0. Here also it is 1 divided by 2, which is 0. Here it is 2 divided by 2, which is 1. Here it is 3 divided by 2, which is 1. So we will use this same remainder and division while assigning the variables in our code. Let's head to the coding now. Okay. Yeah. So first thing we need is we need some place to store our result. So let's create a string builder where we can store the result. Okay, string builder result is new string builder. Okay, now let's also initialize carry to 0. Initially carry is 0. Then let's calculate the length of each of these strings. Let's consider I as a length of a dot length minus 1 int j equal to b dot length. So we are doing minus 1 because like arrays, the character at string char starts from 0 to length minus 1, which is why I am doing minus 1. Okay, now we have to start from the end of the string and process until we reach the start, which is while I is greater than or equal to 0 or j is greater than or equal to 0. As long as there is a value in any of the strings, we will do this. So what do? We find the x and y and do a sum with the carry. So let's find x. So how do we find x? X is nothing but a dot caret of I. So a dot caret will give you its character value. In Java, you can access the ASCII value of a character using the char data type. So, for example, if you do something like 1 minus 0, you will actually get a numeric value 1 because you are subtracting ASCII value of 1 with ASCII value of 0. ASCII value of 1 is 49, ASCII value of 0 is 48. So your answer would be 1 in this case. Similarly, if you do 0 minus 0, you will get a 0. So to convert this character to integer, we can actually subtract its ASCII value of 0. Okay. So with this statement, what we are doing is we are converting the character at that value to its integer by subtracting the base ASCII value, which is 0. Okay. So if you observe the ASCII chart, it for 0 to 9, everything is in sequence. The value goes from 48, 49 to 57. So when you subtract 48 from 48, you will get 0. When you subtract 49 from 48, you will get 1. Okay, that's the same logic we are using here. Now we are doing a OR here. So I may go below 0 as well. So we have to handle that case as well. That means we have to do this only when I is greater than or equal to 0. We are checking this because this is a OR condition. It is OR when I or j is greater than or equal to 0. So one of them can go below 0 when they are not of equal size, which is why we have to check individually. If I is greater than 0, j is greater than 0. Okay. So if I is greater than 0, only then we will do this. So if I is not greater than 0, by default we'll take it as 0. Okay. We can do a similar thing for y as well. So to get y, we have to check if j is greater than or equal to 0 and we have to get the character at j from b. If j is less than 0, we will default it to 0. Okay. So at this point, we have x, y and also a default carry. Now we can do the sum. By doing this sum, we will get values like 0, 1, 2 or 3 based on carry x, y values. Okay. So far, these are all still decimal numbers. Now we have to convert them to binary. So we will use the same division logic which we did. So for the result or the value string would be reminder when you divide by 0, which is result dot append. Okay, some percentile 2. Reminder you will get it when you do a percentile operation. And the new carry would be whatever you get when you divide that sum by 2. Okay. At the end, you have to do I minus minus, j minus minus and continue processing. Okay. Now, this completes processing and at the end it will break when none of the strings exist. But at this point, we might still have a carry. Okay. So, we have to handle that as well. So, if carry is greater than 0, we have to append the carry to the string. Okay. Now, one thing to observe at this point is we are processing the string from the end, but we were appending the result in the regular order. So, our actual result would be reverse of what is there in the result. So we have to reverse before returning the string. Okay, reverse is a function on string builder. We can use that. So this is our method. So what we have done, we have taken a string builder result. We initialized carry to 0. We got the length of A and B strings, and as long as a character exists in either A or B, we got the integer value of the number at that character. We did a sum on the carry. Here we will get values like 0, 1, 2 or 3. From that we found out what will be the value at this decimal point, value at this location and the carry, and we decremented the pointers. Okay, if a carry exists after processing the string, then we added the carry as well to the result. Now since we processed from end to the start of the string, whereas result is in the regular order, we have to reverse the result. Okay, let's run this and see. Let's submit it. Okay, now coming to the time complexity and space complexity. So this operation, okay, so this operation is order of size of the string, whatever is maximum. Let's say if m is the size of A and n is the size of B, we'll take order of maximum of m comma n. Okay, this carry operation is order of 1. Reverse is again order of m comma n, order of max of m comma n, order of max of m comma n, because result will have the maximum length of the A or B plus 1, which is why this will also be order of max of m comma n. So our resultant time complexity would be order of max of m comma n, where m and n are size of the two input strings respectively. Okay, now if we look at the space complexity is here we are taking a string builder. So this again will take the size of max of A comma B. Okay, these are all constant operations, so there is no extra space. Again, in this result dot append, it might take extra space in the worst case, that is when it has to double the space or anything like that. So that can also take order of max of A comma B, length of A comma B. Okay, this is a constant operation. Reverse is in place, so reverse is order of 1. So overall the extra space we are using is order of, again same as time complexity, order of max of size of A comma B. Okay, so the time complexity and space complexity are both in the order of the maximum size of the string. Okay, hope you understood the problem. Do practice and improve your coding skills. Please like, share and subscribe. Thank you.